It's a fixed quantity. Quantity is measured in moles. You have a fixed quantity of gas at 2.4 atmospheres in a sealed container. So what else is staying constant?
Volume.
Volume. Right. At 34 degrees Celsius. And you're changing the temperature of this system to 48.5 degrees Celsius, and you're asked to calculate what the new pressure is. So one way to solve this is to take the ideal gas equation, set it, or solve it for what you're looking for, in which case this is pressure. But do it in such a way where you set the two ideal gas equations equal to each other. And then you can cancel out what has stayed fixed or what is constant. And then
Give me glass, Holly.
and then that's going to give you that new pressure. You could take the original measurements and either make up values for them. Just say that it's 1 mole of gas in a 1 liter container, because you don't know what the numerical values are. All you know is that they stay the same. So you can do it one of 2 ways. But I'm going to leave it to you to, not goldfish, but flounder, and use the ideal gas equation to solve this, or answer this question. But, again, when you're not given the values and you're told that they stay the same, the easiest thing to do is to just make, like in this case, the number of moles 1 and the volume 1 liter, because then it's a lot easier to work with ones. You could make it 5.38 moles if you wanted to, but why would you do that? You could say that the container is 4.44373 liters, but again, why would you do that? So if you're not given values for them and they stay fixed, use values of 1. Or you can do, like I said originally, you can take the ideal gas equation and 2 ideal gas equations and set them equal to each other and solve for that missing variable, which is pressure.
Whoa.
Okay, all I've done here is I've solved the ideal gas equation in black to represent the initial conditions, and then in blue to represent the final condition when it's at the new temperature. So and I could have done this for moles. I could have solved it for N and set them equal to each other. So what I did here is I set the ideal gas equation with the initial conditions equal to the ideal gas equation with the new conditions. The number of moles cancel out, R cancels out because it's the gas constant, and that leaves me with T over P, initial T over P, and then final T over P. And then the following steps, all I did was solve it for the new pressure. So again, that's not the only way to work this problem. You could have, Rachel, what did you get?
2.5.
Okay. So again, you could have chosen an arbitrary number for number of moles and volume and plugged it in, or you could have done it something like this, wherein you set the ideal gas equation in its initial conditions equal to the ideal gas equation in the final condition. And you can do that because, again, 2 of the variables remain unchanged. Actually, yeah, 2. 3. Volume remains unchanged, R is the same for both, and it's a fixed quantity. So there are different ways of solving this, but just be aware that it's not always going to be, here's P, V, and V, and N solved for T. There's going to be some higher level thinking involved in these problems.